Today we're going to add an extra step to what we were working on last week. Last week we were adding fractions with unlike denominators, and today we're going to have one more step, which is that we'll have regrouping. You'll need a copy of today's notes, and if you've got it handy, it's helpful to have a blue and red colored pencil or crayon in addition to your pencil. Before we get into today's notes, I'm going to briefly review with you the concepts of improper fraction and mixed number. We looked at this way back a couple weeks ago, so I want to refresh your memory on how to do this. Improper fractions are when we have a fraction that is greater than one whole. So like any other fraction, the numerator is the total number of pieces we have shaded. In this case, it's 5. And then the denominator is always how many pieces we have in one whole. So we would represent this picture with the improper fraction of 5/3. And again, it's improper because the numerator is larger than the denominator, which tells us we have more than one whole. We can rewrite improper fractions as mixed numbers. And as the name kind of implies, an improper fraction is kind of an improper way to write it. So whenever we give a final answer to a problem, the mixed number is the preferred way to give that. So for a mixed number, it's called a mixed number because it's a mix of a whole number and a fractional leftover. So the whole number is written in large print, and then we write the fractional leftover part and smaller than it. So we have 1 2/3 is the mixed number here. Let's review one more example of that. So here I've got a bunch of pieces shaded. As an improper fraction, I would write the total number of pieces shaded, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 as the numerator, and my denominator will be the number of pieces in one whole, which is again thirds in this case. Now I can take that improper fraction and write it as a mixed number by writing how many whole pizzas I have, 1, 2, 3, and then writing the fractional leftover part, 1/3. So both 10/3 and 3 1/3 are two different ways of representing this picture. But again, an improper fraction is considered improper, and so the preferred way to give a final answer is as a mixed number. One more review, if we have an improper fraction, let me show you mathematically how to turn that into a mixed number, because that's what we're going to do as our last step in our problems today. So if we have 5/3, remember this is really just going to be a division problem because fractions and division are related to one another. In fractions, we're taking a whole and dividing it up into pieces. And when we're doing division, we're starting with a group and trying to figure out how many groups of something we can make. So 5/3 is a division problem where the 5 is the pieces we have, and we're trying to make groups of 3. How many groups of 3 can we make if we have 5 slices of pizza? So the division problem here, I can make one whole, then I multiply 1 times 3 is 3, then I subtract, 5 minus 3 is 2, and that remainder, instead of just writing R2, gets written as a fraction. I have 2 slices left over out of 3 total. So that's how we would mathematically find the mixed number for this improper fraction. Let's look at one more example. Looking at the one we did before, 10/3. To turn that into a mixed number, I would write the 10 on the inside. I have 10 slices of pizza, and I want to know how many whole pizzas I can make if there's 3 slices in each one of those wholes. So I divide what number times 3 gets me the closest to 10 without going over. That's 3. And 3 times 3 is 9 when I multiply. So that's how many slices I'll use up making my 3 wholes. And then I'll subtract, tell me that I'll have 1 slice left over, and I write that remainder as a fraction, 3 1/3. So that's the last step that we'll be doing today in our problems, is taking mixed number or improper fraction answers and turning them into mixed numbers. Whew, all right, now let's go ahead and actually look at your notes. Today we're going to be adding fractions with regrouping. And so what's going to happen is sometimes when you add fractions, you end up with a sum, a total, that is greater than one whole. When you add them up, you're going to end up with something bigger than 1. And when this happens, you do need to do an extra step. You have to rewrite your improper fraction as a mixed number. That's considered the mathematically correct way to give your final answer. So let's do 2 problems with pictures and 2 without. So we have 5/8, and we're going to try to add a half to that. The denominators are different, so we're going to have to go through our 3 steps to get them to have this common denominator. So we'll find our LCM of the 2 denominators. So we're going to be using 8 and 2. Oops. So multiples of 8 are 8 and 16. Multiples of 2 are, there we go, 2, 4, 6, and 8. And then if I look at these, remember I mentioned this last time that sometimes one of the actual denominators is the LCM. So in this case, 8 is the LCM. Step 2 is going to use that LCM as our common denominator. So we're going to make equivalent fractions that both have 8s. Step 3 is to find our missing numerators. This one's really easy. 5/8 stays as 5/8. 1/2, 2 times what gives me 8 times 4 on the bottom. So times 4 on the top gives us 4/8. And you can see how those are equivalent. So now that we've done that, step 4 is the easiest step where we add those equivalent fractions. So I'm going to be adding 5/8 plus 4/8. And let's look at it as a picture first. I'm going to start with my 5/8. So I'm going to go ahead and color that down below here. And then I'm going to add 4/8 to it. And as I do that, I'm going to fill up the circle that has the 5 in it, and then whatever I have left over goes into the next pizza. So I have 4/8, 1, 2, 3, 4, ends up being here. And so that gives me a total of 9/8 altogether. So 5 plus 4 is 9 out of 8. And as you can see from the picture, that improper fraction can be rewritten as a mixed number, where we have, step 5, turn it in improper fractions into mixed numbers. We're going to write 1 whole and then 1/8 left over. And so our final answer for this problem would be 1 and 1/8. Let's look at the next one that has a picture with it. We're adding 2/3 plus 3/4. So the denominators are different, so we'll have to find a common denominator. So we're going to find multiples of 3 and multiples of 4. Multiples of 3 are 3, 6, 9, and 12. Multiples of 4 are 4, 8, and 12. So our LCM is 12. There it is. And now that we found that, we're going to go ahead and use our LCM as our common denominator. So we'll set them both equal to fractions that are equivalent to 12ths. Step 3, find our missing numerators. 3 times what gives me 12? Times 4. So multiply by 4 on the top. 2 times 4 is 8. So 2/3 is equivalent to 8/12. You can see how those are equal to each other. On the bottom, 3/4. 4 times 3 is 12. So on the top, we'll multiply by 3 as well. 3 times 3 is 9. So 3/4 is equivalent to 9/12. And you can see how those are equal to one another. But now we have the same size pieces, so we can add them. So our step 4 is adding them up. And again, we'll start with our 8/12. Go ahead and shade that in down here. And then we're going to add our 9/12 to it. If we're doing that with a picture, we're going to just color in as many of the 12s as we can to fill up this first circle, and then we'll keep adding until we get to 9/12, filling in the second circle. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's our 9/12 combined with our 8/12. Mathematically, 8 plus 9 is 17. So as an improper fraction, this is 17/12 that we see here. And then using that picture, you can quickly turn that into a mixed number, as our step 5 is. We can see we have 1 whole, and then we have 1, 2, 3, 4, 5 leftovers. So it would be written as 1 and 5/12. That's our final answer. Now let's go ahead and take a look at some problems where there isn't a picture. I'm going to still show you the picture on my video, but you won't have it in your notes. So we're going to look at how we can mathematically think through this when we don't have all of those pictures to color. First of all, I did go ahead and slide the M for the multiples over here off to the side so that it would fit on the page. And as I've mentioned before, I know some of you are getting to a point where you don't have to write the LCM out. You can solve it in your head, and that's fine. That is perfectly fine. If you can figure it out without writing it out, great, one less step. This one I am going to write out, though, because these numbers are pretty big. So I've got multiples of 6 and multiples of 8. So counting by 6s, I do 6, 12, 18, 24. Multiples of 8, 8, 16, 24. And with these larger numbers, I have to go all the way out to 24 to find my least common multiple. So my LCM is 24 here. Step 2, I'm going to use that as my common denominator. And step 3, I'm going to find my missing numerators. So 6 times what number gives me 24? Times 4. Multiply by 4 on the top as well. 5 times 4 is 20. On the bottom, 8 times what gave me 24? That's times 3. So I multiply by 3 over there and multiply by 3 on the top, and I get 9 24s. And I did go ahead and show you the pictures on my video just so you get an idea of what it looks like. You don't have to color or write these out. So there's my 5 6, and you can see how, 24 pieces, that's pretty ridiculously tiny, but it takes 20 of them to equal 5 6. And then over here, my 3 8 looks like this. It's equal to 9 24. So those are equivalent fractions now. So step 4, we're going to go ahead and add those up. So it's 20 plus 9. Of course, we know our denominator will be 24. We'll start with our 20, and then we're going to be adding 9 to it. And as we work with these bigger numbers, sometimes it is helpful to actually just go off to the side somewhere and write that addition problem out. So in this case, it's 20 plus 9, of course, is 29 total. So that's 29 24. So that's what that looks like. Now, that improper fraction does need to get turned into a mixed number. So mathematically, to do that, it's a division problem. I'm going to put the 29 total slices I have over here, and I'm going to divide it by 24 because that's how many pizza slices it takes to make one whole. How many groups of 24 can I make in 29? Dividing that out, I can only make 1. I'll multiply 1 times 24 is 24. I go ahead and subtract. 9 minus 4 is 5, and 2 minus 2 is 0. So I have this remainder of 5, and I'll write that as a fractional leftover, 5 24s. So my final answer here is I've got 1 whole and 1, 2, 3, 4, 5 left over out of 24. So my final answer is 1 and 5 24ths. Whew, let's try one more where we're going to solve it with just the math in front of us. We're going to add 4/5 plus 3/4. So let's find our LCM by listing the multiples of our two denominators. Multiples of 5, 5, 10, 15, 20. Multiples of 4, 4, 8, 12, 16, 20. And finding my least common multiple, I do have to go all the way out to 20 to find my LCM. Step 2, I'll use that LCM as my common denominator. Step 3, I'll find my missing numerators to get my equivalent fractions. 5 times what gives me 20 times 4, multiplied by 4 in the top, and 4 times 4 is 16. And that's what that looks like. 4/5 is equal to 16 20ths. Again, those pieces are ridiculously tiny, but notice they're equal. If I take 3/4 and turn that into 20ths, it would be 4 times 5 is 20, and then 3 times 5 is 15. So 3/4 is equivalent to 15 20ths. That's what those two fractions look like. So now that I've got those common denominators, the pieces are the same size, and I need to go ahead and combine them and add those equivalent fractions up. So when I do that, of course, my denominator is going to be 20, and I'm going to start with my 16 20ths and add 15 to it. And as I said, oftentimes when you're looking at bigger numbers like this, it's helpful to just somewhere on your paper off to the side, go ahead and add those two numerators together, and you might have to write it out to do it. 6 plus 5 is 11, and then 1, 2, 3 gives me 31 altogether. So we have 31 20ths. And again, I'll show that to you with the picture. Here's my 16. I'm going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's what they look like added together, 31 20ths. Now we've got to go ahead and turn that into a mixed number to give our final answer. So we'll start with the 31 slices. We're trying to divide them up into pizzas that have 20 slices in a whole. So I divide, how many groups of 20 can I make in 31? I can only make one group. I'll multiply 1 times 20 is 20. I'll subtract 31 minus 20. 1 minus 0 is 1, and 3 minus 2 is 1. So I end up with 11 left over, and I take that remainder of 11 and write that as a fraction. So my final answer here is going to be 1 whole and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 left over. 1 and 11 20ths. Now that's all you have to do for today. Tomorrow you're going to do a graded assignment where you practice this skill with 6 problems. And I would encourage you before you start tomorrow's lesson to actually rewatch this video one more time. It'll kind of help keep it fresh in your brain. And when you're not having to write it at the same time that you're watching it, I think it'll help you pick up on a little faster. So you have 6 problems to solve, and there is a riddle at the bottom. I did want to clarify with the directions that you are finding the riddle answer in a different way on this worksheet. In this case, the directions tell you that you are going to cross off your answers. So since there's 6 problems, there are going to be 6 of these where you're going to cross off your answer because you found it. And then to solve the riddle, the leftover letters that you didn't use and didn't cross off, you're going to rewrite those in order to solve the riddle. And then again, send me a copy of your completed assignment when you're done.